to get that started. There we go. All right, it has started. So this particular meeting, we can certainly talk about lots of things, but I think as a starter conversation, we were going to discuss, sorry, I'm just pulling it up here, how things went this semester, what plans you have for next semester, given what you've either learned this semester or what you've been doing this semester. And then we can maybe sort of broaden that out to how we being, sort of the broader sort of PICUP leadership can help facilitate things in different ways. So because Michelle is in the upper left-hand corner of my screen, Michelle, could you please tell us how things went this semester for you and what you have planned? I noticed it looks like the hackathon's coming together.
Yes, it is. I'm super excited about it. And actually finding funding was a lot easier than I expected, so that was good. But in terms of computation in class, I think the update is the same as the last time we talked, in that I had no pushback from students. They all responded like extremely enthusiastically to the addition of some basic Python, where I don't ask them to write it from scratch, but to work with code and edit code in the lab portion of the second semester intro class. The main issue was time on my part. So at the beginning of the semester, it was going really well for everybody. And then as the semester went on, it was more of a struggle for me to keep posting good content for them related to the work they were doing. So yeah, that's pretty much how it went. So I mean, I'm really happy with the feedback on the computation part of the class. I think for upcoming semesters, I'm really debating next semester on whether or not I'm going to try to integrate computation the same way that I did this semester, because I am teaching 2 new classes, so neither are the same. And one of them is computational physics, which I don't have any material for currently. I've just chosen a book. So that's just on me personally, where I had 1 class this semester, and so I had more time. And so I don't want to like half-ass it next semester by trying to get things into the intro class when it's 1 of 2 classes and I haven't taught either of them before.
I think Kevin has a question for you, Michelle.
Oh. Give it to me.
I'm sorry, I texted it, but I missed it. What courses were you just teaching this last semester that you were just describing?
Yeah, the second semester calc-based intro. So it was E&M, circuits. We had modern for the last month.
Oh, good. I'm especially interested in that because I'm about to teach 122 myself in the second quarter. So I've got 2 sections of it this coming quarter. So to hear what you did.
Yeah. I didn't have much. When we got to circuits, I didn't really think of anything really useful. So I just kind of stopped for that portion. And I was doing it in conjunction with the lab, which I don't know if that's the best way to do it or not, but it's where I could find the time. But yeah, I'm happy to share with you what I've done.
Great. Because I don't know who's next, but since I'm talking, I because mine's going to be short. I just joined this group, just a few weeks ago, the last AAPT meeting, and so I haven't done anything this quarter, but I'm looking for ways to start this upcoming quarter. And as I say, since I'm doing the second quarter E&M class, that's what I'm looking for right now.
Kevin, can you maybe introduce yourself to the rest of the group? I'm not sure that we've all met you, because some of the folks here were at this summer workshop, and it sounds like you connected in a different way.
Right. So obviously you can see my screen. Kevin Wheelock. I'm at Bellevue College in Bellevue, Washington, and just a hop, skip, and a jump away from UW. And we're a feeder. We're a 2-year feeder college for University of Washington.
So you got hooked in through the sectional meeting that Marie and Norm were at. Is that right?
Are those the names? I want to say Heidi. I'd have to look up the emails, but yeah, through an AAPD sectional Washington State AAPD meeting that was just about a month ago or so.
Very cool. All right, so we will go from Kevin on my screen to Rob.
Am I unmuted? I'm unmuted. Okay. My touchpad is a little touchy, or a little untouchy sometimes. Anyway, so this semester I did the 2 intro courses, the calc-based and the not calc-based. I didn't really get to do anything much with the not calc-based. With the calc-based, I expanded a little bit on what I've been doing with VPython for a while now. Had some success with that. And then at the end of the semester, I decided to try a larger project. And I also gave them an opt-out for that so that they could do a series of shorter exercises instead of doing the project. And they went about 50-50 on that. The projects were pretty good considering it was the first time, and I actually gave them a pretty free hand with what they wanted to do. And the people that chose to do projects really wanted to work independently, so they were not particularly seeking out aid when it came time to actually put their projects together. As far as what I'm doing in the springtime, I'm thinking I'm probably going to try a longer or more shorter things instead of the 6 longer things that I actually did this semester. So maybe 1 short thing a week instead of 1 longer thing every 3 weeks. But that's kind of where I'm at on my thinking with that.
Rob, I'll just ask, so how are you deciding to make changes in going from the longer to the shorter things? Like how are you making those decisions what are you chunking things into?
So what we did this semester, we did a lot of the sort of simulating things. So we were studying harmonic motion, and we created some oscillators, and we were studying planetary motion. So we, created small systems, and I have a whole series of exercises with that I've been using for a while. So I've been piecing those things together in terms of application rather than sort of introductory theory. And I'm thinking that particularly for the second semester, some of those things like the field simulators and mappers and stuff might work really well sort of on the other end as the introductory piece instead of the summary piece.
Hey, Rob,
yeah.
Remind me, you introduced the students, this is their first experience with this, with VPython, I believe, right?
My students' first experience, yes.
Yeah, so you take them through from getting them started all the way through doing these things, right?
Yes.
Yeah.
And we had pretty good success. I mean, there's limitations and stuff. I started out trying to use notebooks, and then I couldn't get the graphing function to work correctly or to work at all really in Notebook. So I kind of abandoned that and moved on. Was
that the Jupyter you're trying to use?
Yeah. And I still don't know what the solution to that is. But I liked that there were aspects about the Notebook that I really liked, the way that it was able to compress and introduce in a sort of step-by-step fashion the nearly working code or sort of minimal producing code, and then work on modification off of that, and so on and so forth. But then I went back to the straight VPython when I couldn't get it to actually do what I wanted to do, and didn't really have time to learn the other stuff well enough to teach it. I'm thinking if I have some time in January, I'm going to try the trinkets with the students. I did one trinket exercise with the student, the one that Ron had written over the summer. And that actually worked pretty well as far as it went. There's a little bit of trick to that, in that it doesn't seem to remember, it doesn't save. So I'm thinking there as well, at least, because every time they came back to it through the WebAssign into the trinket, it was reset to native status, which is what you'd want, I suppose. But it made it kind of tough for them to finish it all in one setting.
Rob, I was sort of curious about your comment that your students really wanted to work independently. Was that something you hadn't planned on, something that you pushed back on and kind of gave in on, or did that work well, or what? The reason for my question is I'm anticipating a similar reaction, and I'd like to have some clues as what's the best practices way to respond.
Well, I don't know. It was not what I expected to happen. I expected them to spend a lot of time working with me pretty directly on the projects, and they just sort of went and ran with it. So I think if we had talked about it more as we went along, the end product would have been better. But I'm not convinced that they would have gotten more out of it, as opposed to working on it on their own and sort of running with it on their own.
Do you have any sense of whether the students worked with each other rather than with you?
Yeah, actually, I did have them. I allowed them to work in small teams, and they all put themselves together in teams of 2 or 3, the ones that actually went that route. And that's a good thing, and particularly with my students, because a decent chunk of my students are computer science students who are mostly trained in like C or C++ or one of the C versions. So they have a somewhat different idea of the programming piece, and then they work sort of with somebody else. And in at least 2 of the cases, they were working with people that were more sciencey oriented. But I had, out of 6 groups, I would say a couple of them were 1 or 2 science students with a computer science student, and I had 1 case of 2 science students and 1 case of 2 CS students working together.
Thanks, Rob.
Okay.
So next on mine screen is Sean. So Sean, maybe you want to tell us a little bit about how things went this semester and what you have planned for the following?
Yeah. So I did trinket glow script exercises with my intro mechanics class, and I also taught upper level E&M. And the one thing that I did with that was designing a lab with. So they did a measure. So we just added a lab to our upper level courses. This is the first semester that we've had that. So we they had where they were measuring the capacitance of a parallel plate capacitor, but that was of dimensions where you actually had to do, it wasn't really like an infinite parallel plate capacitor. So designed a lab using MATLAB where they solved Laplace's equation using that. So that was like I taught them or introduced it in one lab session that didn't have a otherwise scheduled time. With the trinket in the intro class, I think it started out well, and I had them bring laptops to class and work on some exercises in class, and then have homework exercises. But it kind of petered out, partly because the stuff that I had designed was more focused on looking at kinematics type things and forces. So once we hit energy, it was a little bit, I didn't have as much material to work that I had planned out. And then also just, I got real busy with job applications and travel and things like that. But I did bring in a few extra, demonstrations in class of things. So like one cool thing that I made just last week was learned about using an inverted pendulum as a model of walking. And so I coded a little walking guy. And so showed that in class after we did the derivation. So next semester, I don't know that I'm going to be able to do much in my intro class because I'm teaching the second semester of it, so the E&M, but it's going to be 63 students, which is a full, literally full lecture hall for us. So there's it's a little bit harder for me to connect with each student in class, and the lab is, doesn't have any computational components, so I'm not sure that I would do anything there, but I'm thinking of trying to do a little bit more in the statistical mechanics upper level class, maybe do some sort of a longer term project with students.
So I'll say I've run into the same kind of issues in introductory mechanics and moving from like forces in motion to energy and then to angular momentum in terms of, finding the right sort of type of thing to have them do. I don't know if others have had that experience too, but it seems like the forces in motion, I have a very good sense of what I should have them work on. And then when I move beyond that, I get a little stuck.
I have exactly the same problem.
Is there some place we could create a repository with if people come up with ideas, and that way we're not all solving the same problem independently?
I'm glad you said that, Kevin. So, so I think that the Slack team sort of is sort of a space for that. There are channels there, so channels would be like chat rooms, if you will. And there's a channel devoted to introductory mechanics. So yeah, if folks have ideas, I would be certainly happy to post some of the things that we are doing with energy and angular momentum for folks. But yeah, iterating on it in there and then sort of projecting it out would be fantastic. I would be very on board with doing some thinking with folks over the break.
What's the status of the exercise sets on the website?
Good.
Kelly, you want to take that one?
Question. Yeah. We are beginning the review process now. We've been on hold for about 3 months, to be honest. So we've got all the editorial stuff in place, so you should be hearing soon. Yeah.
Okay.
So I meant to send out, well, this weekend I'm going to send out nudge everybody that be aware something's going to be coming down the pike. So thanks for your patience on that, Sean, and everybody else. I have to make a confession. This semester about wiped me out. So that's my story, and I'm sticking with it. So, but we are back in the saddle and ready to roll. So stay tuned, all right?
All right. So in my screen here, Josh, I think you're next. So how'd things go this semester, and what's it looking like for the next?
Things went well. As I discussed in our last video conference, I've been running lab-style seminars for introductory mechanics and upper division mathematical methods of physics. And these seminars meet 2 hours per week every week during the quarter. We have 10-week quarters, with the exception of a couple of weeks. And the material in the seminars ran somewhat parallel to the class material, but not exactly the same. And in each seminar, every student was paired up with another student, and they would pairs code the entire time for 2 hours, basically using instructions that were written in a Jupyter notebook and with very little input from me. There's also a learning assistant walking around along with me, checking in with students, probing them and making sure they're on task and answering their questions. And in the beginning, I felt like things were not working exactly as I'd hoped. There's sort of a bit of a learning curve when it comes to making collaborative work collaborative coding work properly. But I found that especially when students got to know their partners better, it was really great. I mean, the discussions that people had were awesome. I really love the pairs coding paradigm. I think I'm definitely going to try to do it again. I found, for example, that when students are debugging their coding in pairs, you just get such much richer conversations about what the problems are with their code and what the solutions are, for example, or even richer discussions about the different prompts that I gave them in the Jupyter notebooks. So I thought it worked really well. I have to say that I too am a bit wiped out primarily because of these seminars. It was significantly more work to prepare for them than I had expected. So it's not for the faint of heart running a coding lab. I'll tell you that, especially developing all the material yourself in real time. But having done it, I think it was really rewarding. And for the next quarter, I'm going to be teaching 2 pretty large enrollment, like 200 per person student classes, one on introductory E&M and the other one on like modern physics and optics and things like that. So I'm not going to have, I don't think, the energy to do this lab thing again for 2 consecutive quarters, but I'm looking into a new avenue, which is kind of where I want to go in the future anyway, which is more organic integration of computation into those classes every week. I'm going to explore trying to use trinkets to do that, and in particular, write reasonably easy problems that people with little coding experience could do from week 1, basically. So my hope is to have maybe one problem every couple of weeks on the homework assignments that's a coding problem relating to the material, and have it require them to interact with a Python trinket.
I have some questions for you. So first, I think you were asked this on Slack, but you selected the pairs for your seminar, is that correct? And then they stayed with the same pairs throughout the whole semester for the same partner?
Yeah, so originally I selected the pairs according to programming ability. In particular, I surveyed them before the seminars and asked them to rate themselves on their programming experience. And I paired one reasonably expert programmer with one reasonably novice programmer. But we actually found that this caused some tension in certain groups, in that some people really were so much better and faster than others that they just got super frustrated and didn't want to slow down to say, explain something to their partner or whatnot. So we mixed the groups up a little bit to try to see if we could get some better matchings. And after we mixed them up, we stuck with those matchings for the entire quarter. And I've at first was thinking of mixing them up every single time, just so people would get to have different perspectives. But we found that by getting to know each other, they got a really nice rapport, and that their working process became really smooth. So I actually really liked the fact that we just stuck with the pairs and then had them develop a relationship with each other, and they worked really well in teams after that.
Okay. And so you said that the seminars were 2 hours per week. Was that 2 1-hour sessions?
It's 2 hours in a row.
Okay. Because I was trying to think for my computational physics class if it would be plausible to do like 20% of the class, like something lecture based, and then have the rest of the class be pair programming, if they would be able to accomplish enough in that amount of time to make the pair programming useful. What do you think?
Well, I guess that depends on what you want them to do, like how much content there is. But my experience has been that students are remarkably good at getting a lot done when they're pairs coding.
Okay.
More than I would, enough that it became annoying to me because I had to create more material for them to do.
So they actually completed things faster than if they were on their own.
I think it's hard to say because I haven't given the same material to people to do on their own. But at least I felt that they were doing things in a more complete way in the time that they did them.
Mhm.
So it's efficient, in my opinion.
Okay, thanks.
Great. People keep moving around here. So, Suraj, I think you would be next to share out. Yep, that looks right.
Can you hear me? Yeah, okay, so this semester I've been doing intro physics, calculus-based physics, some mechanics. We just right now on, we did some thermodynamics, oscillations. We're now on ideal gases, and that's where we'll end this semester. And I've also been teaching the equivalent of computational physics, sophomore level. I haven't introduced any programming in intro physics. My plan was to introduce something, and then I decided that it's best to wait until the second semester where they'll do E&M, and I have a better idea of what I could do in E&M with the programming. In computational physics, our courses taught in the past has been taught only in C, but two of my colleagues who were at the workshop in summer had decided that they want to introduce some computation in upper level classical mechanics and another course. And so we decided that we will introduce, and they want to do it in a Python, VPython. So we decided that we will introduce, in addition to doing most of the computational physics in C, we would spend a couple of weeks on Python. So that's what I've done this semester, is incorporated a couple of weeks of Python in my computational physics course, which is largely C, just so that when they do get to classical mechanics, I think either next semester or the semester after that, and they have projects to work on in VPython, it wouldn't be the first time that they're seeing Python. But I do have plans to incorporate some programming in the second semester calc physics. That's it for me.
Sarush, when you did the Python, did you give them some basic code framework for them to expand upon, or did you throw them into the pond?
Yeah, well, no and, and no. So how I do the course is I have about 32 students in the course. We are in a computer lab on campus, so each student has a PC. So they're sitting in front of a big monitor. They can. So I introduce a topic, and we proceed during the course of a 50-minute session to write some code to use to explore the topic for the day. And typically I would have not every class, but every second class I would have a small sort of project for them to work on at the end. So where they would have to write their own code. Usually it's editing the code that we wrote during the class to use the new function that we introduced that day in a different scenario. So the code that they would use for that would be code that they would have written along with me during the course of the class. Yeah, so for example, with Python, we just finished the 2 weeks of Python. The last day we were doing, and I used Jupyter Notebook, and it really made teaching this topic easier compared to C. We did chaotic maps. So we did the logistic map, and it was great because we could make the graphs right there in Jupyter Notebook, whereas in C there's always an issue of how do we plot the data file. Right, and invariably somebody will pull up Excel or Origin or some obscure thing that I've never seen before and ask me to help make their graph. So with Jupyter Notebook, we were able to write the code and make the graphs there, and also do all the nice things like zoom in, have a look at different parts of it, and then what they did at the end of the class was, in about 15 minutes left, I gave them a function for the tent map and basically asked them, all the features we just described, bifurcation, fractals, periods, chaotic regions. This is the function for the tent map. See if you can identify make the graphs and see if you can identify all the regions. So what they had to do was take the code that we had just developed for the logistic map and now just apply it to a different function, which is not as simple as just swapping out the functions. So that's what I did. Our computational physics is we meet 3 times per week for 50 minutes at a time.
Great, thank you.
All right. I think next in my panel here is Chuck. Chuck, would you mind introducing yourself to the rest of the group? Mainly because I don't know you.
Well, I was at the AAPT meeting back in October, and I just started learning about all this PICUP stuff, and I got on the Slack channel, and I've been really excited to try and implement this in my class. I haven't actually done it yet because we were part of the way through the quarter, but I did convince a couple of engineering instructors to implement some of the PICUP exercises in their engineering class, because we have a couple of classes where we teach students how to basically model things in Excel and then later model things in MATLAB. So we're going to have them use I think the harmonic oscillator one. We're going to have them model it in Excel, and then we're going to have them in the next class model it in MATLAB, and hopefully they'll see what the power of that is. So that's kind of where I'm at right now. I'm just kind of hoping to listen to you guys and how you do it, so I can start to implement this in my physics classes as well.
And where are you teaching at, Chuck? Sorry.
Oh, I'm teaching at Edmonds Community College in Seattle.
Chuck, I forgot, who did the workshop with you? Was it Marier and?
It should have been Marier and Norman, because I didn't go to that one.
Oh, okay.
Yeah. That was
Marier. Okay.
Marier and Norman.
Right. Oh, good to have you, Chuck.
Yeah, hi.
Sean, you get to go again. No. Hunter is next on my list here. So Hunter, we're talking about, you're probably picking it up here, how things went this semester and what are some plans for next semester.
Okay, well, I tried a variety of things. I think I'm pretty much, I don't have any real news since our last meeting, but I know not everybody here was there. I tried trinkets in my sophomore level waves and heat introductory calculus based class, and I had a laptop cart that I pulled into the lecture hall and had them check out laptops and pull up trinkets on through our learning management system. And either they had to, either the trinket worked and they had to modify some parameters, or it didn't work and they had to enter some formulas to get it to work. I like that okay, except for the fact that we have to wheel in the laptops. But eventually, if we can reliably provide computing resources, I'd like to be able to have lots of trinkets to go with whatever it is that they're doing, especially if what they're doing is perceived as less rigorous because of its conceptual nature, which I don't think is less rigorous, but I think the students can perceive it that way. So I think computers help to give it some numbers and some, more of a geekier feel. And in my quantum class, we've been using Jupyter notebooks some, and mostly just trying to, I didn't quite have the nerve to give them design scenarios as much as I did want to give them, a program that I wrote that, didn't have the probability density or something, and then I wanted them to add that, just to enhance it a little bit, because we still, at Texas State, we still don't have a formal support for them to learn the Python, but which we're going to start that next fall. We're going to have a lab course for sophomores where all of the physics majors and minors are going to take that. I also had a small working group of students that were doing an independent study with me, and we worked through Kinder and Nelson, Python for Physical Modeling, and then also some problems in Newman's computational physics book. And, at the end, I sort of tried to reflect on what would be good experiences for this sophomore course that's starting next fall. I've also got a couple of students that I'm doing research with where right now we've been developing a visual editor, a block, drag and drop blocks editor for VPython, GlowScript. And so we're now kind of trying to form partnerships with a computer science professor. Let's see, there's UT Austin has money from the state. It's for a project called We Teach CS, and they want to increase the number of computer science teaching certifications. So we're going to get involved in that, and the idea is to get some teachers in math and physics or whatever to cross over and add CS as a certification through 60 hours of PD that we're going to put on. So the computer science professor that we know saw our work on the blocks and the trinkets and stuff and thought it was pretty cool and wanted to include us. So we're going to be teaching teachers pretty soon something. I don't know exactly what. And then we're also meeting with on Thursday, we're meeting with the CEO of Trinket to talk about doing a curriculum partnership. And I don't know exactly what that means, but it's the name of the thing on their website, Curriculum Partnerships, and we're going to meet him and see what can be done.
Very cool.
And also, I got to say, just for fun, we visited Continuum Analytics in November, where Anaconda's from. That's Austin on 6th and Lavaca or something. So we went there and met Travis Oliphant, the of NumPy, and that was pretty fun. That's it.
Hunter, the fellow that you're meeting, or I assume it's a guy because it's a technology, that's sexist, sorry. Is it Brian Marks?
No, it is Elliot Hauser.
Okay.
And he has a beard. He or she has a big beard.
Yeah, so Brian Marks used to have a big wizard beard. He worked at WebAssign, and now he's a chief something officer at Trinket. Maybe he's the technology officer.
Okay.
But he had,
okay.
yeah, I don't know.
Or lead
Probably doesn't remember me, but if you see him, say hi and well, don't stroke the wizard beard, but admire it.
Well, this is going to be a video meeting.
You'd still admire the wizard beard.
If there's a beard stroking emoji, I won't press it. Or no, I will press it. Okay.
All right.
I'm glad we're recording this.
I can't wait till Norman sees this.
Oh yeah, this will be
great.
Yeah, get ready.
I actually have a question, Hunter. You said you had used Kinder and Nelson and the bit of Newman's book. What did you find the main differences to be that are salient, and like which do you prefer for what sorts of things? If any?
Well, it's a very different experience. Newman is full of problems, application problems that relate to this or that physical scenario. So it's, at the end of each chapter, you're applying some computational concepts to a wide variety of physical scenarios. So it's really has a feeling of a senior level elective course, where you've seen all these, you know what black body radiation is, you know what a Lagrange point is, whereas in Kinder and Nelson, it's very light on physics and good for, I think, and it's definitely introductory. And it's so I think it's going to be good for a sophomore level course. I also got, on the recommendation of one of those students in my group, hang on a sec. So this is a book that one of my students got who felt like she couldn't really keep up with the math in Newman. And so, it had a lot of positive reviews, and so I'm just going to look at it and see if this would be another good sophomore level thing where there's math that and then you're just learning the Python to, the math is sort of comfortingly familiar. but it doesn't look too simple, so I'm not worried about it.
Who's the
Sorry, who's the
author?
author for that one? Yeah.
What's that? The author is Amit Saha.
Just paste it in the Slack channel, y'all.
Hmm.
Any other questions for Hunter? All right. Well, we will move over to, let me make sure I've gone through this. Tony. So we're just sharing out how things went this semester and what's the plan for next semester. You need to unmute yourself.
Okay, there you go. Can you hear me? Yeah, so I was saying I don't know how things went exactly, but I had shared what I had done with my students earlier on. Oh, Chuck and Kevin. My name is Tony, and I teach at BSc. I just forgot to introduce myself. I teach at a 2-year college, so primarily university physics and college physics, which is the stuff that scientists and engineers take for introductory physics. So I use VPython, and I dabbled in I've even forgotten its name. What's
GlowScript, Tony?
GlowScript, yeah. So I didn't really have a very good experience with GlowScript. I guess I should have dabbled with it a lot more. So I went back to VPython and just used VPython for the rest of the semester.
Tony, what are you saying you should have done?
Well, I should have kind of worked more with it because I had some problems that were basic and they frustrated my students. So I just went back to what I knew, So I probably need to work more using GlowScript. But VPython worked fine for me, so it wasn't a problem. I have a little girl here who wants to show her face. But anyway, so next semester I'm planning on continuing with VPython with E&M. And so I just use the traditional matter and interactions, which nowadays has scaffolding. So it has the VPython in the book itself. Though my students really don't use it. I do have exercises that I give them where they do computing in the lab, and they also do experimental labs. Hey. So that's about all. I mean, do you guys have questions for Terry?
I want to know what went wrong with your GlowScript.
No, it wasn't really that it went wrong. It's just that I was uncomfortable with it, and my students were also uncomfortable because I used VPython and then went back to and then told them that, well, GlowScript is better because you can save your programs there. And I think I had an issue with an operating system, and then I had an issue with just not. It was a formatting issue, or and then it just spiraled into a problem that students kind of became like, GlowScript, we don't want to deal with GlowScript because it has too many issues. I can't debug well. So it wasn't really a major problem.
I agree with you.
Yeah.
The debugging is almost non-existent.
Yeah. But I still like the idea that your programs are right there. So that's great.
So, Tony, one thing that we had talked about, I mean, I don't know if it might not have been you and I, but it might have been the broader group at some point, was trying to develop some tutorials for faculty around sort of the major, platforms that people are using, whether it's something like GlowScript or, how do I use Trinket or how do I use Jupyter Notebooks? Do you think that like, if that kind of thing were available to you, it would be something that would be helpful in sort of navigating a new environment? Like, is that something we should be thinking about?
Absolutely. I think it will be very helpful for me. Once I get into the semester, I'm usually drowned. In fact, right now, I'm just setting an exam here. So, yeah, summer is usually great for me, but after I get into fall and spring, yeah, there's just nothing. No time to do anything. So that would really be helpful.
Okay. Yeah, I mean, I think it's something we've talked about. I mean, Kelly and I and the rest of the leadership group, and it's so we can think about that a little more.
Yeah.
Okay, I
got a quick general question about GlowScript. I have not yet delved into this a bit. Rob, you still use VPython, don't you? Oops, can you hear me?
Yes, I can hear you.
Oh, okay.
Again, having difficulty unmuting myself.
Oh,
Yes,
it's okay.
Python.
Well, I just wondered because yeah, well, Hunter said there's some I don't know some glitches or something. Is that true of this GlowScript in general?
The error messages are very poor quality. That's, I mean,
okay.
But so what I do now is I try to build in Spider. I mean, except that Spider doesn't have access to VPython, but I make other kinds of errors, and Spider can help me with that. And Jupyter Jupyter has pretty good error feedback. So I'll develop in there. But I mean, frankly, now I make fewer errors, and so I'm able to develop in Trinket just fine. I think it was, so Steve Wolf was in this meeting last time, I think, and he said that since this summer, Trinket, I think at the time of our workshop this summer, Trinket was using GlowScript, and then GlowScript were providing different error feedback. But then, as a request sent to Trinket, then Trinket was just displaying the error feedback that GlowScript was getting. But still, they're both not helpful, and they're not even Python errors; they're JavaScript errors, I think.
Yeah.
So you need to develop in a different environment and then port it over, or just have a higher level of facility that you can catch your own.
I was just curious how that was going. I don't know. I suppose Aaron is very much aware of all of this, I guess.
Aaron Titus?
Yeah. Okay. That's all. I'm just curious.
I don't use, I guess part of how I debug is, I don't know, it's a little advantage where Trinket has the code and the output side by side, whereas the GlowScript website has you toggling back and forth between your code and your output. So the GlowScript website to me is dead, except for the documentation where I go occasionally. But I just do all my GlowScript work in Trinket.
Okay. That's good to know.
Hunter, have you tried using any of these things within Jupyter notebooks with any success?
Any of which things?
Like VPython, for example?
Yes. Yeah. So like if, for the quantum simulations that I've done, I needed to use NumPy and at least NumPy together with VPython. And as far as I know, if you want to use any, popular Python libraries and VPython together, it has to be Jupyter or the old classic VPython, but I don't want to use that anymore. I don't want to touch it.
Did you find that was reasonably easy to implement?
Jupyter?
VPython in Jupyter notebooks, yeah.
Well, I had some difficulties back in September that are documented on Slack, where I managed to get Danny in real time one day, and Larry was chiming in too, and it was a matter of I didn't understand about WebGL being activated in the browser, and also didn't know how to make sure I had the latest version of everything, or didn't know how to, I now have a better understanding of how to probe the computational system that's in front of me to understand what libraries are active, or what version of Python I'm using, and so it's easier to diagnose because I know some sort of key tidbits, for diagnosis. And then I got the systems up and working, and then they work. And then could I fix a broken system? Maybe not. Maybe not.
Did you ever try mouse interactions in VPython in Jupyter Notebooks? I think that's the only thing that I couldn't get working, but I could get working in Trinket.
Oh, mouse interactions. No, I never tried that.
Okay.
I think, Michelle, just as a technical question or technical answer, the way that the canvas is drawn in a Jupyter Notebook is different from the way that it is drawn when you use something like GlowScript or you use something like VPython. I mean, it's not a canvas in that case, but there seems to be slightly problematic when you go to get a redraw, like when you request a redraw. And so I noticed with working with my students, because when I was teaching upper level E&M this semester, and we did Jupyter Notebooks, and sometimes we did VPython. If they made a mistake with where the canvas statement was, redrawing their whatever it was that they were doing became problematic, and they had to kill the kernel and start it over again, and we had to figure out where it had to be. So I think it's a problem that Bruce is aware of, but I'm not sure that he knows how to solve it.
Okay, so are you saying that you have gotten mouse interactions to work in?
Nope.
Okay, because it was my understanding that people have gotten it to work like on the internet, but I haven't met any of these people. Okay.
My sense is it has to do with the way that the canvas gets drawn and redrawn,
Okay.
and that is not the bugs aren't fully out of that.
Okay, thanks.
Hey, Danny, we don't use a canvas statement at all in Jupyter, but we do have to restart the kernel every time we run the program.
If you use the canvas statement, you won't have to.
Really?
Yeah. Usually, yeah. Not all the time. Not all the time. Usually.
Can you write down what that statement is so that we can save ourselves some time?
Yeah. I'll put a note to myself to post something that has the statement in it somewhere.
Okay.
Yeah. Okay. I believe our last participant who hasn't shared yet is I think it's Deepshika. Is that right? Is that who DS167?
Yes.
There we go. All right. So
yeah, I basically had simpler programs embedded in my lab section to go concurrently with lab as an alternate means to look at the same things. And it was mainly force and motion, like position, velocity, acceleration, force, dynamics, or projectile motion, or collisions even. But I think by and large they went well, but there were a few students that probably struggled more than the others because they did not have a computational background. But since it was a lab setting, they worked in groups, so in the end, it did not matter that much. They could, teach each other and help each other. And I was, and I don't have a really big class, so that's good. In fact, what I was able to do was I was teaching algebra-based as well as calculus-based intro mechanics, and I was able to. Well, one plus point of not using matter-n interactions this semester was that I was able to use the similar computational sort of programs for both classes. Since they were embedded with the lab, I could do that with both simultaneously. So that was the plus point. Next semester, what I'm thinking is this semester it felt more like bits and pieces. It was a strain on me as with all of you. So next semester, what I'm thinking is when I teach E&M, I'd go with a combination of lab as well as what Josh suggested, I guess, include at least one computational homework problem with every set. That way they are continually thinking about it, rather than when I give a computational piece in the lab, that's when they think about it and then forget about it. So I guess repetition would be what I would be looking for next semester.
Cool. Any follow-up questions for Deepshika? Okay. Well, I'm sensitive of the time, and I'm glad everyone got to share out. If people have just a few more minutes, I wanted to just kind of ask more broadly, and people can jump in as they feel. Are there things that we as either the sort of leadership council or PICUP more broadly could help do or help facilitate? As far as incorporating computing in your courses, helping you to do that. Are there things that we can provide support for or sort of organize the community around?
Posting a troubleshooting document.
It occurs to me that if there's sort of a one-stop shop for students to get documentation on coding, obviously, a little Googling will find you anything on anything, but if we had something we could put in our syllabus that points them out that they want to find out how to do this in VPython or do that in regular Python or so on, that might be useful.
I know we focused a lot on implementing computation in the curriculum, but I'm at a point with my department that I'm trying to push for more computation broadly in the department. And I'd find it useful to have resources that facilitate that for me. In particular, for example, if I'm in some sort of academic affairs committee meeting, it would be nice to have a list of what other institutions are doing with computation, so I can take that list to them and say, look, I'm not alone in wanting to do this stuff. There are a lot of institutions doing this, and we should be considering this too, for example. Or any other resources you can think of as a means of motivating administrators to give this attention.
Josh, it's interesting you bring that up. You are now, we have been contacted directly by 3 other places very recently. I guess one of the reasons, if you type into Google computation, education, that sort of thing, we come up, right? PICUP comes up. And so there's Syracuse is one, University of Minnesota is another one, who are at the state that you're describing here. And they're asking about pretty much the same thing, departmental level resources to not just what to do, but to help convince colleagues and administrators. So we're definitely putting this on the list. And I think maybe, Danny, we can create another channel on Slack with this. At very least that, but I think we'll make a broader effort towards creating resources for this. I don't know what form it'll take yet, but that's on our radar.
I was wondering, just along these lines too, if PICUP leadership would be willing to, say, give talks either by video conference or fly out to convince departments to do things.
Sure.
Josh, I'll go to LA anytime. I hear they have good food.
Weather's not bad. So Josh, the answer is yes. So I just did this very thing at Illinois Wesleyan this last week. And I went and gave a talk and tried to do some convincing. I call it evangelism, I guess. So I think that any of us you don't, just doesn't have to be the PICUP leadership. I think, a lot of you can articulate as well as I can. So I think if there's a need, we can meet it if it becomes well defined enough. I think you'll have enough willingness to chip in and do whatever it takes. So but I think in an official, we'll try to develop more materials along these lines.
So along these lines, one thing that I would find useful is if we had a document that we all collaboratively agree on, where this is kind of a response to the AAPT and APS's declaration that computation is important. So something where we are saying, you know, we now are providing this resource for physics professors in response to these.
Excellent idea.
Kelly, since we're spitballing here, what about something that's like an editorial for Physics Today that the community, the broader PICUP community now drafts, right? That highlights sort of resources and so forth. I mean, maybe not right now, but in the next couple of years, as a way of saying, like, there are people, lots of people behind this doing lots of different things,
right? And
there are resources out there, and the department should be aware of it. And we can have some. I mean, we can have some of the survey data can be highlighted in there. And
definitely.
Kind of like a broad sort of discussion of the whole effort. You know, with the usual high energy physics author list.
Is the new survey data available?
It is not, Rob. We have just closed the survey, as I understand it, and we are just beginning the analysis. And by we, I mean the AIP.
Back to the question of resources real quick, and I think, Kevin, you had mentioned a central repository of resources. We have our web developer back in the saddle, and by the way, Sean, part of the hiatus on those exercise sets is we haven't had our website developer back with us for quite a while, but we're ready to roll now, back especially the first week in January. The reason I'm bringing this up is we're going to be spending over the next semester a lot of effort in thinking about what goes under that resources tab on the PICUP website. And maybe we should have maybe one of these or a series of these types of meetings to talk a little bit more in depth about that, because it's only going to be successful if we all contribute to it. I mean, I and Larry and Danny, and we, for those of us who really like to do this thing, we can get stuff created and put it up there. But it's really all of you contributing and being a part of it. So I want to not only welcome you, but urge you to, if you have great ideas of things that should go up there, and anything's game as far as I'm concerned. One thing, let me just give you a quick example. At our workshop last summer, our developers workshop, Ernie Beringer, who I think some of you know, if not, we can introduce him. But he made a point. You'll like this one, Rob. That he says he's a novice guitar player, and I think he's a little better than novice. He's a humble man, but he says anytime he wants to learn a new song, he goes to Google and types in the name of the song and guitar lesson, and there it pops up. And he thought, wouldn't that be great to be able to do that and have a nice, not somebody giving a lecture on the Euler method, for instance, but just a quick 30-second idea to give you the essence of what that's all about, right? And so these are the kinds of things I think would be unique and very usable for people in general who would wander on our site or would want a resources of these kinds of things. And that's just a simple example. So,
Kelly, I think you've suggested what's a really good next meeting for us. Maybe late January, early February meeting, and I'll get a poll going out for folks, which is to talk about and brainstorm sort of resources. So sort of combination video meeting and maybe an open Google document for all of us to take notes in and get a sense of what that resources page should look like, what should live on it. And then maybe, the following meeting starting to try to assign maybe some responsibility and get people to lend their own expertise to it. Because people have been doing lots of different things from what I've heard over the last two meetings.
Yeah.
How do folks feel about that? Does that sound like a interesting shift instead of, okay.
And this is all, this isn't just the PICUP leadership thing. This is your thing too. This is your ownership. We want to,
Okay,
this could be as cool as we make it. Go ahead, Hunter.
No, I was just going to say that I feel, I think a lot of us feel like we're included, we're not, I don't think we're trying to pass the buck to you, to do something.
Mm-hmm.
In fact, I plan to seize power relatively soon.
Well,
and then you're going to appoint all of your own people.
Well, this way I don't have to spend so much time writing the next grant. So,
as a newbie, maybe I can help confuse things even more. And the particular resource that I am familiar with is Sage and Sage Cloud. And I'm never, obviously, I've seen a review. One of the things I discovered recently is that it is a very good environment for coding in straight Python, and it supports NumPy and SciPy and Matplotlib, and you can make nice, cool graphs and even animations. So that's another alternative for as far as Python coding is, and along with, I guess you're already familiar with it. It's algebraic computational facilities. So.
Mm-hmm.
Yeah, that's actually what I used for the seminars, Kevin. Also.
Yeah, I use that for Python in my computational physics class because we didn't get anything installed on the computers in the computer lab in time. So that was really useful for us.
Well, that being the case, then I'm not sure about the Jupyter notebook interface because I use the classic interface with Sage, but you can publish your workbooks, and so they're non-interactive, of course. But we talk about sharing stuff with each other, and that's a way to do it, and just share links around. And I run my own Sage server off my own web server as it happens, and I've got a number of things published there. So.
Great. All right. So I want to make sure I'm respectful of folks' time. It's now 9:13, at least here on the best coast, the third coast.
Your invitation has been rescinded.
You know what? We got the most fresh water, so there.
Lansing's not by any water.
That's right. We'll never have a drought. Anyway. So I want to thank you all for joining us. I really appreciate you all sharing and the conversation, and I'm really looking forward to the next meeting.
Yeah.
I think we're starting to sort of coalesce around some stuff that's gonna really support this community and grow it out and really try to get other folks involved. So I really appreciate that. So I will be in touch because it looks like I'm the de facto organizer here, Kelly, which is great for me. So we'll try to get something on the schedule as long as I'll send a poll out to make sure that sort of Tuesday evening still work for folks in the spring, and then we'll try to schedule something late January, early February. But I'll probably send that out after the first of the year so that folks have some time to decompress after the semester.
And it's Monday.
What's that?
That's okay. Daddy doesn't know what day it is sometimes.
What day is it? Monday?
Monday.
Oh, that was.
Oh well.
And if you go Tuesdays, you'll lose me.
No, we'll stick with Mondays.
Yeah, we don't want to lose anybody.
Right.
We'll stick with Mondays. I don't know why I thought it was Tuesday. No, I know why. Anyway, I wanted it to be Tuesday.
Right.
Yeah,
all right,
Monday.
folks. Well, have a good finals week if it's finals week for you, or have a good break if it's already break for you. So, and have a good vacation.
Happy holiday.
Hey.
Yeah.
All right.
All right.
Nice to meet you, folks.
So,
Yeah.